All right, I started the recording. Hi, everyone. So as you all know, this meeting is recorded and will be uploaded to YouTube. We don't have any items on the agenda, but I guess we can go through the list of tasks that we've set for 1.18, unless anyone has a specific topic that they would like to discuss. Okay, so I'm looking at the spreadsheet. Let me ping this spreadsheet on the chat. So the first item was the framework migration. So this one is done. Basically, all the predicates and priorities have been moved. The algorithm directory has been removed. Dependencies on daemon set controller on kubelet has been removed as well. Cluster autoscaler is in the process of integrating with the framework. We removed all the old interfaces that they used to depend on, which is mostly like creating a full scheduler and calling the predicates manually. They're not able to do that, but the good thing is that we finished early, and so they have over a month, actually almost 2 months, to change to create a framework and run the plugins and whatnot. And they are in the process of doing that. It seems that it's working fine for them so far. I was tagged on their PR. It's a lot of effort for them to re-render the scheduler, but I guess they have enough time to finish before the code freeze. We also moved both the queue sort and the bind logic into their own plugins. We are discussing modifying the semantics of post, actually removing post filter and adding pre-score, since all the instances of using that extension point was basically as a pre-score in the default scheduler. So it might make more sense to just call it that. And then other than that, I think that's it. From now on, we can call the schedule like is moved now, and we can just look for enhancements. Maybe try to add extension points if necessary. Modify, for example, to modify the preemption behavior and whatnot. Does anyone have any questions about the framework or comments? Multi-config scheduler. You want to say something?
Well, just that we have the CAP approved for implementation, and since there's a few related changes to this, we are bumping up the component config API to V1 Alpha 2.
Sorry, you're talking about the second item now, right?
Yes.
Okay, so yeah, the second item is multi-config scheduler. Yeah.
Yeah. So yes, I created a tracking bug for the all the changes that we plan that are related to V1 Alpha 2, namely multi-scheduler configuration, removing priorities arguments into the plugin config, and deprecating scheduler algorithm source, so that the only way of configuring the scheduler is plugins now. Well, will be. Yeah.
So that's good. Anyone have any questions related to this effort and generally moving component config to V1 Alpha 2?
Can we just rename the item to multi?
We can't hear you.
Profile. Can you hear me?
Oh, maybe I am muted.
I can hear you, Wei.
Oh, yeah.
Okay.
I'm muted.
So basically, can we rename the feature to the same name as the CAB? I think it's called multi-profile scheduler.
Multi-scalar profiles.
Multi-profile.
Yeah. You mean in the...
Yeah, just in this ratio. Yeah,
right. And the third item is, so this is in progress. Is making the scheduler's default topology spreading configurable. And that's part of this effort as well, I would imagine.
Yes. So my initial proposal was to have the default configuration in the main component config, but now the proposal has been changed to use the plugin config. This is going to be much cleaner, and it's also included as part of V1 Alpha 2.
Sounds good.
But yeah, I would say it's basically blocked on the previous, on multi-scalar configuration. I want to get that first.
Improving schedulers benchmarks. So yeah, Chung has been working with the community. I think they got a new benchmark framework, let's call it, not the scheduler framework, but another framework within the integration scheduler perf directory that allows creating benchmarks by simply specifying like the pod spec and node spec, I guess. So it's easier now. So you basically specify the characteristics of your workload the same way that you specify it when you normally interact with Kubernetes, and then from that you can have it's easier to create new benchmarks. I think one sticking point there was how to collect the metrics. We needed some logic from Prometheus that was not exported. We tried to fork it into Kubernetes, and there was some pushback from the maintainers with the project. And so we might change our approach. So that logic basically computes the percentiles from a histogram metric. But I guess if there's resistance to copying or forking the code from Prometheus that computes the percentiles from histograms, we can just predefine some buckets and report distributions across these buckets. So that's also in progress.
So the framework is for both integration and end-to-end, or one of them?
So this is a benchmark framework, basically. Benchmarking, not executing on a live cluster. It's like in your machine, basically.
Okay.
Like this, it's exactly the same for the same exactly has the same purpose as the ones that we have right now. It's just like makes it a little bit easier to create new benchmarks.
Right. New scenarios.
New scenarios, yeah. Right, and then graduating a support list. I'm not sure what the progress of this one, to be honest. I can follow up on this one. Graduating the kube scheduler component config to beta. So this is postponed. And then we have now because we are moving to alpha 2, because we are changing the configuration to allow multiple scheduler configurations in the same component config file. So we're going to V1 alpha 2 first, and then moving to V1 beta 1 in the next, in 1.19, hopefully. Scheduler framework plugins. So that's way.
So right now the subrepo has been created, and Alex have the cap about the code scheduling. So that raised an interesting idea to just use QSOT to achieve the goal for code scheduling. So both me and Abdullah did a first round of review. I will review more on the technical details, but generally that idea looks good to me. So it's opposed to some general implementation like keep recording the ready paths, the pending paths or something. So that idea is sort of neat to me, but we need to take a close look. And also in the community, there's another guy who wants to contribute their idea of doing plugin for respect some specific paths. For example, the terminating part or something. I can't remember the details. So that could work as a out of tree plugin as well. So I suggest them to open a cap to us and we'll review that. And one another thing is that, as Aldo pointed out, so because it's a subrepo, so basically it seems that we should not keep the caps in the repo Kubernetes /enhancement. Instead, we should put into our subrepo and review the design details and implementation there.
Sounds good.
Yeah. So the expected goal of this item is that by the end of this release cycle, we have a repo with a couple of plugins contributed by different vendors, and we have good documents guiding the people how to write this plugin and a real plugin implemented and exercised by the large companies. That is our goal for this release.
I remember that the code scheduling cap mentioned something about using post filter, or maybe I might be wrong.
Post filter.
So we need to make sure that the changes we are making are not.
Like, I get your point. Yeah.
I don't know how. Yeah. Okay, sounds good. Please, if you have any ideas for how to enhance the scheduler, post them into, either discuss them on the mailing list or on Slack, so we can add them to the spreadsheet and track them. Make sure we have progress. We make progress on those ideas. So there are a couple of things that we discussed over the past couple of weeks. One that might be worth discussing in the SIG in the SIG meeting. One is head of line blocking. And the second one is what to do with terminating pods in the context of pod spreading, pod affinity, anti-affinity, and whatnot. Which one do you guys believe is more interesting to discuss first? Because we only have 12 minutes, and unless you have a third item that you also would like to discuss and believe it's more urgent.
Just one thing, there is some lines are commented, like promote the 10-base eviction to GA, promote the pod to pod spread failure. Right. So yeah, we can add them. I already commented. You just need to resolve them. Basically, there are two features we want to promote that. One is from beta to GA. One is
so yeah, this is a good point. So one thing, I think the most important thing to discuss now is Mike, are you going to lead the conversation with SIG apps or SIG node to take ownership of that feature and node, lifecycle controller as a whole?
Yeah. So I did reach out to SIG apps. I talked to Mache, who I think is in this call.
Okay.
It's just like we did get a lot of the work done towards getting taint-based evictions to GA based on the issues that we had. It's just at the last minute we kind of had that confusion about which SIG should own this. So I'm going to lead that and try to find out where we can definitely pin down who needs to own this. And after that, it should really just be a bookkeeping thing because, like I said, we do have a lot of the work done to update like the feature gates and the tests. So besides that, it's just docs changes.
And then Descheduler Go modules. Do you want to comment on that? What was?
Yeah, that's just a quick comment about that. I opened this about a week ago, trying to switch the descheduler to use Go modules. The problem with it is that there were a lot of places that it depended on upstream Kates.io/Kubernetes, really just for a lot of helper functions and it was referencing some internal APIs instead of like using case.io/API where it could have. So unfortunately, the best solution that I could get for some of those helper functions was just to copy them to our own utils package. They're pretty simple. They're all like just parsing fields in a pod and trying to figure out like, namespace and things like that. But it hasn't really gotten much attention. So if there's anyone that can get some review or maybe offer up some insight as to other places that these helpers could be coming from that we could actually depend on as a module, that would be good because we should be moving this to Go modules.
Okay. So I guess we can quickly talk about terminating pods. I guess we kind of reached to an agreement where terminating pods is not a terminated pod from the scheduler's perspective. So we shouldn't really consider a terminating pod as pod that doesn't exist because it can potentially have some resources reserved to it by other components, specifically the node and kubelet. And so when we evaluate generally like whether a pod can fit into a node that has a pod that is terminating, whatever resources assigned to that pod should still count against the allocated resources on the node. So basically, we're taking the more conservative approach here. But for other cases like pod spreading, some people in the community feel that it might not be so bad to exclude terminating pods from the computation of pod spreading. Basically, if a terminating pod exists in one topology, then we shouldn't really count it against the skew because eventually that pod is going to go away. It's not, from pod spreading perspective, it's not a resource that it's holding. It's just like a computation for availability. So it makes complete sense to consider that pod, unavailable, because it is actually terminating. So it will go away and it will reduce the availability of the service. And so anything we do for computation, for computing the skew should take that into account. Does anyone have any you want to comment on this? Do you guys have any concerns about this conclusion? Okay.
I think we can link the issue of our discussion here. Let me paste that.
Yeah.
My general concern is just to try to avoid special casing if possible. The particular example that they provided, like I feel like it shouldn't be solved with spreading. Like a daemon set would be more appropriate, probably, or something like that. But yeah, on the other hand, I think just special casing spreading is not too bad.
Yeah, I mean, the idea there is that like, again, it's not a resource that it's holding. And so we're not concerned that the pod will get, rejected by the kubelet because we made a decision based on considering a terminating pod as something that will be deleted in the future. So there's a lot less risk there. And it's actually like, if we think about pod spreading as a feature to enhance availability of a service, it makes really complete sense to say terminating pod should count against, should not count against like that. This pod actually, it does spreading and offers you an availability. So we should, okay, sounds good. The second, the other item is, and maybe we can discuss in, I don't know if we have, is head of line blocking. So there's been like two or three issues been opened regarding head of line blocking in general. So
I, by the way, I merged them. I closed all of them and kept one to simplify our discussions.
right, and Aldo found a bug in the approach that we're taking for back off. Even like the back off strategy that we have right now it's not behaving as expected, because the back off gets cleared completely way too early, while it should have lasted as long as the pod hasn't been deleted yet. Like if a pod is being backed off, for example, 1, 2, 4, 8, and then reaches its max back off, should stay at its max back off as long as that pod is not getting scheduled. For some reason, we had some logic there that was garbage collecting that history, and then a pod some pod that reached its max back off could have had its back off resetted back to 1, even if it was like in its 10th try and whatnot. So that bug has been fixed by Aldo. It will be backported to previous releases, but it might not be enough to solve this problem completely. So it's something to think about. It's something that maybe can be like a new effort in general in the SIG. Maybe not a small effort, like something that we need to think about. Maybe change the architecture of how we handle unscheduled pods, changing our approach completely. So I guess the best path forward is we need probably to bring, like we did some brainstorming on that issue, but I don't know what the community feels about this. Should we, is this something that we should care about a lot? Is this something only triggered by some extreme cases that typically should not occur unless someone is shooting themselves in the foot by creating way too many high priority pods that can't be scheduled? Like in this scenario, like I don't imagine why would you do that if you then like if you're not provisioning enough resources for those high priority pods, then those high priority pods are not actually high priority. Yeah. So if anyone has any feedback or want to comment on this subject.
So one idea I can think of is that, so right now, as we have know that the pod spec priority determines two things. One is the QSOP implementation. By default, it's just sorting by the priority. Right? The other thing is it determines the preemption logic. So basically, what I can think of is that the priority can of course determine and should determine the preemption logic. Only the high priority pods can preempt the low priority pods. But in the other hand, regarding the QSOP, we should be open to access more logic. For example, right now we have recorded the times of attempts for the pod, which has been tried scheduling. So maybe that is a metric we can leverage to make the QSOP logic more reasonable to avoid this kind of starvation. So that is just my initial idea.
To me, like the number of attempts is already factored in through the backoff, right? Like the backoff is
only when it's not enough. I mean, it only read, so it's that, for example, if it's 10 seconds max duration, so when the attempt to reach to 4, right? So it doesn't matter. So it makes no difference 4 and 40. So we should honor that.
Yeah. I mean, like the other thing is, how do we evaluate this? Like, I'll just start with, like, you have this unit test, but how can we create benchmarks representative of such workloads that allows us to evaluate all these different heuristics? Because those are going to be heuristics. They will solve some cases, but they will not address others. And potentially they will harm use cases that we already support right now.
Exactly.
So yeah, the other approach that we've discussed, I guess, is make the events that trigger the moving the pods back from the unscheduled queue into back off or active. You know, more like making more intelligent decisions there, not to move everything. This has also its drawbacks. It's complex to track all the use cases. And so we need to, we need to evaluate those trade-offs. I still, like, we had a couple of cases, you know, a couple of posts on GitHub regarding this thing. But are we convinced that this is actually a problem that needs solving? Or is it something that can be solved with a better, you know, cluster configuration, meaning using resource quotas, or, you know, again, like someone is using pod priority, like is abusing it basically. So yeah, I don't know how to get to that conclusion, whether this is something important or not.
Yeah, the ideal case is that we can use some unit tests or integration tests to reproduce this kind of situation, and then we can have
integration. It's probably quite possible to do with integration. Reproduce. But yeah, the question is it worth investing in this problem?
Well, I guess, yeah, if someone is interested in it, can pick it up. If not, I guess we can wait until we have more cases to motivate the work. Okay, that's all I have. We are 3 minutes past our meeting. Thank you all.
Thank you.
See you.
Right.